If your bearing damage analysis work includes assembly and disassembly of machines or equipment, personal safety must be your top priority. Before we begin our study of the damage modes, we need to review a few points that involve your safety. Warning: failure to observe the following warnings could lead to a risk of serious bodily harm. Never spin a bearing with compressed air. The rollers may be forcefully expelled. If a hammer and bar are used for bearing removal, fragments from the hammer, bar, or the bearings can be released with high velocity. A mild steel bar is preferred since it is less susceptible to fragmenting. Failure to observe the following instructions can result in equipment failure, leading to a risk of serious bodily harm. Proper maintenance and handling practices are critical. Follow installation instructions and maintain proper lubrication. Do not attempt to disassemble unitized bearings. Components may be damaged. Do not use a damaged bearing. When it comes to the handling of Timken tapered roller bearings, remember that everyone's safety is in your hands. Around the world, Timken bearings can be found wherever wheels or shafts turn, but the job of keeping them turning often falls on the shoulders of the maintenance team. That responsibility becomes even more apparent the moment a machine breaks down or a line stops. One of the most challenging tasks your maintenance team will face is correctly interpreting the signs of wear and damage in tapered roller bearings. By the time you finish this program, you will be able to recognize abnormal wear and damage symptoms, explain the causes of premature wear and damage, and identify steps to correct and prevent further problems. A Timken tapered roller bearing is a highly engineered product that features a precise tapered design. Races and rollers converge at a common point, or apex, allowing the bearing to operate with true rolling motion. The tapered profile of the rollers and races generates a natural force within the bearing. This force seats the roller body squarely against the cone large rib during rotation. True rolling motion keeps the rollers properly aligned, minimizing friction, reducing wear, and increasing operating efficiency. Rolling contact occurs between the rollers and the cone and cup races. The bearing's load-carrying capacity is transferred through line contact with the rollers. A small degree of sliding contact, combined with rolling contact, occurs between the roller large ends and the cone large rib face when the rollers are fully seated. After millions of revolutions and loading cycles, metal fatigue may result in an inclusion spall. An inclusion is a very small impurity in the bearing steel. During operation, load is transferred through the bearing where the rollers contact the cup and cone races. Just as repeated loads on a highway cause a breakout of the road surface, the repeated load cycles fatigue the metal in the bearing. This generates cracks below the surface of the steel around the inclusion. As a crack grows and spreads to the surface, the metal flakes away, creating a pit with a rough, grainy texture. The metal debris contaminates the bearing as it continues to operate. You can see why the quality of the steel used to make tapered roller bearings is very important. At the Timken Company, we specify and produce high-quality alloy steel to minimize the size and number of inclusions.